going to be talking about working with the raster array service or raster arrays and the Mapbox Tiling Service today. Before we jump into that topic, a couple housekeeping items. This is going to be recorded and available to everyone afterwards. There's captions available. You can submit any questions you have through the Q&A feature. And any other sessions that you might be curious about, you can check them out at mapbox.com/build. So my name is Jake. I've been working at Mapbox for a little under 2 years now. And during this time, I've worked on a number of different things, but a lot of my focus has been around the Mapbox Tiling Service and adding support for raster and raster-array tilesets to the service itself. So some of the things we're going to talk about today, what are raster-array tilesets? How do they differ from raster tilesets? Why is that an important detail to know about? How can we generate a raster-array tileset? And then building a map with a raster-array tileset that we're going to generate here today, and how we might want to style it just to be able to show data in interesting ways. So what are raster-array tilesets and how do they differ from raster tilesets? There are a number of different differences. In most cases, when you want to represent RGB or aerial imagery, visual imagery, you're going to choose a raster tileset. However, raster-array tilesets provide us some pretty interesting mechanisms to visualize data over time. The difference between a raster-array tileset in the way that the data, the underlying data is stored, is that we're using a single band from our source imagery. So in the case that you're seeing here in this little GIF that I'm showing you is a wind animation. This is using 2 bands to generate the wind particles, but we might be able to represent something like temperature with a single band or humidity with a single band. And so raster-array tilesets will generally use 1 to 2 bands from your source data to represent either scalar or vector data in the way that you want to display that. Another difference between raster-array tilesets is that we have a lot more options in the way that we end up wanting to style the data. So we can color that data in interesting ways. We can provide these particle animations and control the way that these particles are animated. And then we can represent a lot of data over a period of time with that as well. This data is stored as an MRT tile. So it's called a Mapbox Raster tile under the hood. And what this allows us to do is to store a lot of information about a single tile in a slightly different way that we would in a raster tile set, which is just going to generally be a PNG or a WebP. An MRT can contain multiple layers, layers being different representations of data. In the case that I have here, we might have a layer representing temperature and a layer representing precipitation. Within each layer, we can have multiple bands. Now, bands inside of a raster array tileset are a little bit different than the bands you might think of inside of a source image, such as a geotiff. A band in a geotiff is going to represent some kind of data range, whereas a band in a Mapbox raster tile is going to represent possibly a timestamp or some other kind of some other piece of information that might be similar to time. So in this case here, I have temperature over 4 different timestamps being stored inside of an MRT. We can do some interesting stuff with MRTs, such as supporting range requests. This allows us to query for just portions of the tile rather than having to fetch the entire tile when we're trying to render this data. This is a proprietary format, and you do need to use a Mapbox SDK to render the data and the Mapbox Tiling Service to generate a raster array tile set, which is generated with these MRTs. Just some quick little GIFs here I wanted to show through is some of the different things you can represent with a raster array tile set. This first one here is just some precipitation forecasts over Japan. This is temperature data. I think it's over like a 12-hour period of time over Japan as well. An interesting one here is humidity. Humidity always looks pretty cool, and you can style these with different color scales to sort of get what you want to represent out of these data sets. And this last one here is just representation of wind around the island of Japan. So how can we generate raster-array tile sets? Uh, the main way of doing this is through the Mapbox Tiling Service. We need two pieces of information to generate a raster-array tile set. And the first is a source that contains the data that we want to generate the tile set with. And the second piece is a recipe in the form of a JSON file. The combination of those two things will allow us to create and publish a tile set and then visualize that in a map. So let's jump into building a tile set and a map that will represent that tile set. There's a couple different ways that we can interact with the Mapbox Tiling Service. The first is through the series of APIs that are available to create sources, create your recipes, publish those recipes. This is going to be a pretty useful approach if you have some kind of script running in the background that might be fetching data from a source and you want to, on a regular cadence, generate a tile set that represents some precipitation data or some kind of forecast. The other way that you can interact with the Mapbox Tiling Service is the tileset CLI. That's sort of what we're going to be using today. I think this is a really great way to get started with the Mapbox Tiling Service and makes it a little bit easier to prototype a tile set with rather than having to worry about using the APIs directly. Having worked on the Mapbox Tiling Service now for coming up on 2 years, I always am curious about like what kind of data can we represent and what's sort of interesting to view on a map. Having lived in the western part of the United States, one of the things that we often worry about here during the summertime is smoke. And so I've been thinking about how can we represent smoke data in Mapbox using Mapbox Tiling Service. Lucky for us, NOAA has a really cool data set called HER, which has some variables within it that allow us to visualize smoke. They have a page here called HER Smoke, and they publish a lot of different variables here with visualizations of what those might look like. What I'm mostly curious in is near surface smoke, because that's what's going to be most visible to us. And if we take a look at what this data looks like, this is just a single timestamp from the data source. And we can see there's quite a bit of smoke happening in the northwestern part of the United States and some fires and smoke happening down in California as well. And then quite a bit going on in the southern part of the US as well. So with that, we want to be able to generate that in a Mapbox map. And so cool thing about this HER data set is they publish a little user's guide for us. Jumping into that, they have a section here, which variables are smoke related ones. This was really helpful for me when trying to figure out what I wanted to process. Not always are these going to be so easily available, and sometimes you have to poke around the data a little bit more to sort of figure out what's contained within these files and what you might want to generate a tile set from. In the case of this smoke data set that we're going to be looking at, the smoke concentration near surface is sort of the most interesting sounding one for me. And so the variable that we're going to be looking for is mass-den. They publish a list of files every single day on multiple different timeframes. I'm just going to grab a single time band. This is, I think, the observational time band at midnight for September 10th. And let's download that file. So the first thing I usually do whenever I get a data set that I'm not really familiar with is I'll open it up using g.info. This will allow us to just list all of the information that's within this file and get an understanding of what's in there and what we can actually pull and process a tile set from. This file has 170 bands within it. I'm mostly curious for mass-den. So if I search for mass-den, we can see that there is in fact a band inside of this file that has that is labeled mass-den. This is mass density, and the unit that they're using here is kilogram per cubic meter. So this is sort of sounding like what I want to use to generate my tile set from. But the first thing that we're going to need to do is to upload this source into Mapbox Tiling Service. And so using that tileset CLI that I mentioned before, we can see there's a number of different commands available to us. The one that I'm most interested in here is upload raster source. So if we use upload raster source, I'll specify my account name. I'm going to specify the name of the source that I want to upload. So I'm going to call this smoke, and this is from September 10th from yesterday. And we're going to reference that file that we just downloaded. And so this should upload the file for us directly into Mapbox Tiling Service under my account. Once that's uploaded, we have a URI that we can reference in a recipe that we'll generate. So jumping into building recipes, this is sort of the way that you tell Mapbox Tiling Service how to take that data that we've just uploaded into the service and manipulate it into a tile set that we can then visualize on a map. So for raster array tile sets, there's a few things you need to specify first. The first is a version. The version allows us to just say this is the first version of the recipe. We don't have version 2 of recipes yet, so this is pretty much always going to be 1 for now. The second thing you're going to want to specify is a type. There are 3 different types of recipes out there. There's vector, raster, and raster-array recipes. So we're wanting to generate a raster-array recipe, so we'll specify that. After we have that, we need to specify what our sources are. This is just going to be a list of objects that have URIs in them. And in our case, we just uploaded a source into Mapbox and it gave us a URI. So we'll reference that in this sources list. And the last thing that we need to specify in our recipe are layers. Now, recipes can contain multiple layers, and this could be interesting if you want to generate a recipe that might have say this mass density layer, it might have like a visual fire layer, it might have a temperature layer in there, and then we can visualize all those layers on the map using the different layers that were generated inside of the tile set. For this demo, we're just going to talk about a single layer. We're going to create a smoke layer in here. And we're going to have to provide it with some information as to how we want to take the data that we've just uploaded into Mapbox and turn that into a visual tile set and a layer that we can render on the map. The first thing I'm going to specify is the resampling. I want this data processed using nearest resampling. If you don't specify this, I believe we default it to linear. So it's really a visual thing and ultimately up to how you want to style your data as to what you will choose for this value. The second thing we'll specify are the units that we're using here. When we were digging through that file, we saw that the units here were kilograms per cubic meter, so we're going to specify that. This doesn't have an impact on how the data is processed. It's just a useful thing that we can show within the tile set when we're rendering it on the browser or within an application. And the last thing we need to specify here are source rules. So source rules tell us how to take the data and what to extract from it to generate a layer. In our case, this file had 170 bands, and we're really only curious about one of those, which was the mass den band. And so if we generate a filter here, this will allow us to target a single band out of the source file and use that band in our layer. I'm going to give it a couple parameters here. I'm going to tell it to get the grid element. And I've got this grid element a little bit earlier on. Every single band inside of this file had a metadata tag called a grid element. When we were looking at mass den, that grid element value was set to mass den. And so what I want to do here is filter for any grid element that is equivalent to mass den. So this is going to tell Mapbox Tiling Service to grab only that band. We're also going to need a name. Now, name allows us to specify what the name of an individual band within our layer is going to be called. And going back to these bands that are within the source file, we have another metadata tag called grid valid time. I'm going to use that as the name of the bands that we're storing data within. So we're going to get the, similar to our filter, we're going to get the grid valid time, and we're going to use little functions, turn that into a number. And then we're going to order this in ascending order. And this is just going to tell Mapbox Tiling Service that if we have multiple bands that come back using this filter, sort them in ascending order based on their name. So this is the most basic form of a raster array recipe that we can take and generate a tile set from. So let's do that using the tilesets CLI. There's a command here called create. So if I use create and help, there's a few different things we need to specify here. The first is going to be a tileset ID, and that's in the form of our username and then the ID of the tileset. We're going to need to provide a recipe path and then a name of the tileset as well. So let's do that. We'll use my account name here. And I'm going to name this HR Smoke 0910-2025. We'll give it a path to the recipe, and then I'm going to name it the same as the ID here. So this will just allow us to create a tile set that's not yet published. So there's a tile set out there called this, Jake Borowski, HRR Smoke 0910-2025, but it's not usable yet, so we need to publish it. So let's use the publish command and publish that recipe. This is going to send the recipe to the Mapbox Tiling Service and generate a tile set that we can actually view and use within the Mapbox SDK. While this is running, we can actually check the process or progress of the job by using the job command. And this job command takes a tileset ID as well as a job ID. The output of it's going to be in a JSON. So I'm going to use JQ to format that a little bit nicely for us. And it's going to output a bunch of information here. The first thing that I'm really looking for here is the stage. And it looks like it's already succeeded. So we can actually take this tile set and start using it to generate a map with it. Before we jump into that, there's a little bit of information that we need to know before we can generate a map with. And so what we're going to do is we're going to fetch the tile JSON for this tile set. The tile JSON contains metadata associated with this tile set that we've just generated. This tile JSON is, it's going to contain all the layers that exist within a tile set and the fields that are associated with that layer. In the case of this tile set, I'm mostly curious about the band and the data range that is within it. So we're going to come back to these two briefly here, but I'm going to jump into a little map that we have. And we're going to talk about how to take the tile set we just created and visualize that in Mapbox. So this is the blank map that I'm starting with. If we go into the code for this, all we have here is a little setup where we're generating a map. We're using the light style here. And then I have this little hack where I'm setting the map to the map instance on the window. We'll get back to that a little bit later. What we really need to do here at this point, though, is to add the source and layer to the map so that we can start manipulating it. So in order to render these raster array tile sets, the first thing we need to do is to add a source. And adding the source is quite simple. We provide a name for a source and a couple parameters. Important one here is that we need to specify that this is a raster array source. And the second thing we're going to specify is the URL. So the URL is going to be a link to the tile set that we just generated, which if we go back to our terminal, we can get that from here. So just the ID of the tile set, and we'll go mapbox // tile set ID. So this is going to add my tile set that I just generated to my map. Now we need to add a layer in order to visualize that. So if we add layer, we can specify some parameters here. The first is going to be the ID. So we're going to add a smoke layer. Next is what kind of type is this? This is going to be a raster layer. We don't have a raster array layer here, so you can just specify raster, even though this is a raster array source. The source that we're referencing, and that's just going to be the name of the source we just added, so smoke, and then a source layer. And the source layer comes from the recipe that we use. So if we go back to the recipe that we wrote earlier, we created this smoke layer. That's the layer that we're going to refer to inside of GLJS here when we're adding our layer. And once we have that, we can go in and add some painting properties. So this is kind of the point where we're getting into styling our map. The first thing I want to do here is add raster fade duration. This is a property that allows us to control how long it takes between tiles loading. For raster array tile sets, I found that this value tends to work best when it's set to 0. If you have this higher, you might see some interesting artifacts between rendering tiles, so we'll start with that. If we go back to our map, let's see if we have any errors here. Just double check everything here. Okay. So we've created our map. We have a little error where the style is not loading. Just make sure I have everything I need here. Oh, you know what? There's a wrapper that's required. We need to use a event handler here called load. So once the map has loaded, this is when we end up adding our source and our layer. So you can drop that inside of there, and I think this should be enough to render our data. Yeah, okay, so here's our tile set. This doesn't really seem very usable, and it's not, it's just a black square. So this is where having some information around how we want to style this tile set is going to become useful. The first piece of information that we need to have in order to help style this tile set is going to be the range that the data covers inside of the tile set. And we can get that from that tile JSON that we fetched earlier. Inside of the layers that exist within the tile set, there is a range. And so we'll just grab this array and we're going to use that to help us style this a little bit. So we want to add something called a raster color under our paint property. This is just going to tell GLJS as to how to color the tile set. We're going to interpolate between the raster values. So we'll use linear here. And what we're going to do here is use the data range that we just grabbed from the tile JSON and apply some colors to it. So I'm going to just create a variable here called range and set it to that data range that we grabbed earlier. The way that we use the raster color value is that we specify a value in our data range. So we'll specify range 0, the first value in our range, and then the color that we want to use. So in this case, we'll use white, and then we'll grab the second value in our data range and we'll style that with black. And so let's go back to our map and see what kind of impact that had. Oops. Actually, I think this is supposed to be a list. Let's see if that works for us. Oh, thank you. Raster value. One second here. I'm just going to take the earlier version I had of this and drop that in here. Okay. Cool. Okay, so now we're coloring our tile set using two values, white and black. So if we go back to this code, we're taking that first value in the range, setting it to white, and taking the second value in the range and setting it to black. And this is better than what we started with. We started with just a big black box. Now we have white and black. And so we can see there is smoke occurring in this area of what I believe is California. And then there is some smoke higher up in the northwestern part of the US and into Canada. Again, this still isn't very usable, and we probably want something a little bit better than this. So I've prepared a little function to help us colorize this information and represent it a little bit more neatly. So we have this function here called create color scale. And what this is going to do is create an array of equally spaced steps from our data range. And then we're going to use D3 and interpolate using the spectral color range here. So we go to D3 site. This is sort of the range of values that we're trying to represent using that function. We have a bunch of different little functions that can be useful for colorizing raster array tile sets, but I'm going to stick to this spectral one. So using this function, I'm going to, instead of passing in the range and some colors here, I'm going to take that function and pass in my first two values. And what this is going to do is we're going to create 64 equally spaced items from the minimum value of our range to the maximum value of our range, and then apply a color to each of those individually spaced values. So if we go back to our map, we should see something a little nicer. And this is cool. Everything that doesn't have smoke is purple. And as we go deeper into more smoky areas, we can see that it's quite a bit more red, and that turns more and more purple as there's less and less smoke. This is cool, but it's still not great because we can't really tell where we are on the map. One of the techniques that we want to apply here is to remove any area that doesn't have data within it. And so we can do that using this little function that we created. Rather than applying a color for every single position, we'll apply a color for every single position except for the first. So we're going to use a little conditional here, and we're going to say if our position is the first position in the list, we're going to set the color to RGBA 0000. So basically making it transparent. Otherwise, we'll use this D3 function to interpolate between that color range. So if we go back to our map now, this looks a lot cooler. We've gotten rid of that area that has no data within it. And now we have some more interesting visualizations here where we could actually see there's smoke coming up from California and some smoke coming up from Idaho and Washington, and fires further up north in Canada. This is super useful for me. When I go outside after work and I want to go on a hike, I want to be able to see if there's smoke around or if there's going to be smoke in the future. So I think that's where raster array tilesets can become really interesting, is we can start applying forecasts and visualizing data over time. What we've done here is we've just taken a single time band and we've styled it. But what if we had a data set that had a full range of forecasts? That would be pretty interesting to see here. So the cool thing about the HER data set that's published by NOAA is that they do publish a 48-hour forecast, and that comes in the form of many different files. I've already uploaded those earlier, and I've generated a tile set from those files. So we can go back to our terminal here, use tilesets CLI, and just list some of the tile sets I've generated. You do have to specify your account name. And the tile set I'm looking for here is this full tile set. So using this full tile set, we can go in and actually visualize a forecast. So the tile set that we just generated, it only had a single band. this full tile set has quite a few more bands. So I'm going to jump back into the tileset CLI here, and I want to grab the tile JSON for this full tile set and just sort of show you the difference of what that might look like. And the big thing that we'll see here is this bands list. We have a number of different bands now representing the forecast data for this smoke. I think it's a total of 49. The first band is going to be the current state of the smoke, and everything after that's going to be a forecasted value. So we just added that data set into, or that tile set into our map here. But the other thing that changes whenever we change our tile set is the range. The range is going to be the representation of data over the full tile set and all the bands that are represented within that tile set, not just the first band that we generated in our initial tile set. So we want to get that data range for this new tile set as well, and that's going to be just a little bit different than the original. So we'll replace that here. And go back to our map and make sure everything's still loading. Cool, still loading. But we're not animating anything here, and we don't have a mechanism to jump between bands that exist within our tile set. So what I've done here is I've prepared a little bit of code to help us with that. We'll jump into that briefly, but I do need to set up another little variable here in order to jump between steps. So window.startingBand is another little hacky piece of information that I'm going to be using here. But we want to specify what the first band of our tile set is in order to jump from band to band. And so we'll go back to our tile set JSON here, grab that first band, and specify that in our list here. So now if we go into our map, this is the little slider that I just uncommented, and I have some logic that we want to use in order to jump from band to band. Now you can do this in all sorts of different ways, whether you use React or Vue. In my example here, I'm using Alpine just to be able to do this a little bit more quickly with a little bit less work and less setup in terms of how many files I need and any kind of build system. So Alpine.js is going to allow us to really quickly set up some state and set up some functions that will allow us to control our animation. So let me just double check here, make sure I have everything set up. I've got my starting band, I believe that's what we need. And then I do have a couple typos here. I think I called my layer smoke. So we're going to change this to smoke. Double check that. Smoke layer. Cool. Let's see if that works. So sweet. Here's a little animation running. And this is using all of those bands that exist within that tile set to show us a forecast of the next 48 hours of smoke data across the continental United States. The way that we're animating between each of these bands is actually quite simple. Once we've added the source and the layer to our map, we can just modify something called the paint property in order to choose what the next band is within the tile set that we want to display on the map. I'm not going to jump into too much of the state management that we're doing here because I think depending on what kind of framework you're using, that's going to change a little bit. But this is sort of the most interesting part of the state management. Whenever the animation's playing, we take our current step, and this current step is going to be the index that we're running in multiplied by 3600, and that's going to be the number of seconds within an hour. I know in this case, the tile set is representing smoke every single hour for 48 hours, which is why I'm using 3600 here. I'm then going to take the starting band and apply that offset that we've generated here and use that to paint the raster array band on the specific layer. This property allows us to specify what band we want to display. And so as we jump through our animation, we're going to be just picking different bands from that tile JSON. There are different ways of doing this. If you don't have a consistently spaced band index, you can grab all of the bands that exist within your tile set and go through each of those indexes individually. This is just sort of convenient because each of my bands are 1 hour apart, so I can easily use that. So that's sort of what it takes to generate a pretty simple animation using a raster-array tile set. And I think we're going to end here and jump into Q&A. So yeah, do you have any questions, Greg?
Hey, Jake, that was incredible. First of all, well done. I've been saying this in a bunch of the sessions where we go live, but to go live with a demo and, I know you practice, but to not necessarily know how it's going to go, is awesome. So that was great. We do have some questions. So I'm going to start with the first one. Are there any other cool public data sets that you found interesting beyond the HRRR ones?
Yeah, GFS is another really interesting one that NOAA publishes, and it's a global data set that you can generate tile sets from. I've generated a number of different tile sets using GFS to just visualize temperature and precipitation data. Those are sort of my two go-tos, and honestly, the most interesting ones for me most of the time. But when I started researching smoke data, HER was the first one that came up for the United States. I think Europe has some pretty interesting open source data as well that you can use, but I haven't really explored those quite yet.
Sort of riffing off that, Jake, this is a question straight from me, but when we talk raster data, a lot of times we do talk weather data like smoke or, precipitation, whatever. Are there any other types of data that most frequently come in raster format?
Yeah, the most common that we had a little session about yesterday is for our satellite tile sets, right? Like the satellite and aerial imagery. You can generate all of those types of tile sets using the Mapbox Tiling Service as well. Recipes will be a little bit different. You would specify a raster type instead of raster array. We have seen other types of data that people might use for raster array tile sets as well, beyond just weather. I think one interesting one I've seen is displaying the service strength of a mobile phone provider. They've provided data sets that they would generate using raster array tile sets and then visualize those. There's a lot of cool styling that you've seen here that I've applied, and you can see how that could be useful for styling all types of different raster formats.
Okay, awesome. We do have more questions coming in, Jake, so get ready.
Cool.
Yeah. Next one. Now, this was answered via the Q&A, but let's see if we can answer it live as well. How could we create a smooth look to these rasters? Remove the blockiness or pixelated look. Is that a resampling edit?
Yeah, absolutely. So in my option or in my recipe, if we go back to the recipe that I was using here, I specifically chose nearest resampling to give me that blocky look. And then in GLJS here, our painting property actually didn't specify this. I can make it blockier. So you could specify a resampling value here as well and apply nearest. And so at this point, I think this is kind of like the blockiest way that I could have the data represented. If I chose linear interpolate or linear resampling, we can go and have a much smoother look between pixels to sort of avoid this blocky look. I know in some cases, the blockiness is preferred. I think in Japan, they oftentimes prefer showing the data in this more blocky format because this is sort of like the truest form of the data where maybe in the US, having this like interpolated data and having a smoother look between the color values would be preferred, even though it might not be entirely accurate in the way that the values are perceived. It would visually come off a little more appealing that way. So you can control that.
Okay, thank you. Next one for you, Jake. For uploading the time series of smoke over 48 hours, did you have to perform 49 separate uploads?
Yeah, I did. So I had a little script in the background that I ran this morning that downloaded each of the individual forecasted time bands from the her data set. So going back into this her data set, we can see the one that I have highlighted here is the initial band of the time band of the series. And then they have every single hour after that for the 48 subsequent hours. So the script downloaded each of those files and then using the Mapbox Tiling Service API, uploaded each of those as its own individual source that I then referenced in quite a larger recipe. Similar to the recipe that I had here, the same layers were being applied, the same source rules and same filter name. The only difference was that I specified a much longer list of sources here. Now, this changes from data set to data set. Some data sets might contain all of the time bands that you might want to represent inside of a single source file. In the way that this her data was stored, each individual source file only contained a single time band. And so I had to upload all of those sources individually.
All right, thanks, Jake. Do you have a recommended source for wind particles, wind data?
Yeah, so we've actually generated a couple interesting data sets using both her and GFS. And both of those are available publicly for the her data is available for the continental US and Alaska, and then GFS is global data. The resolution on the GFS data is quite lower, and so generating wind particles with those doesn't look quite as nice at higher zoom levels. However, it's cool that you can represent the entire globe. I do have a little demo that I can show of that. So this is using GFS data that we're generating. I think this is actually from this morning, or no, this afternoon. So this is the global data set. And as we zoom in, you can see we're showing more particles, but that resolution doesn't really allow us to go too deep here. Like this is about as nice as the wind's going to look when you zoom in from this higher resolution or from this lower resolution data. If I switch to the her data set, I have also generated wind from this data set. And we have much higher resolution data for wind. So we can kind of zoom in closer to the state level and sort of see these particles in a much better resolution at these higher zoom levels. So both of those data sets provide wind. I think some of the European data sets do as well. And those are pretty cool data sets to dig through. We do have examples and guides on our documentation page on how to generate a wind data set. So feel free to take a look at some of those.
Yeah, while you answer the next question, I am going to find a couple links. Next one. So those questions were from Liam. So Liam, thank you for your questions. This is from Reginald. Is there ever a time where you've had to convert vectorized data to work for raster formats?
So we've seen quite a lot of people do the opposite, where they take raster formats and generate vector data to generate a vector tile set and then represent that in Mapbox. That was sort of one of the driving factors around creating this raster array format was to allow raster data to be processed directly and visualized without having to generate that sort of intermediate format being the vector format. I've not seen it in the other way around, where you're taking vector data and turning that into raster. Though I can't imagine that someone out there has tried that.
Okay, thanks, Jake. And while you were doing that, oh, I commented both of these to the backstage, however. So I'm gonna comment to everyone. Here's docs for creating a wind animation and docs for colorizing your raster data. I posted in the chat for anyone who wants to head to our doc site and check this out. Okay, I believe that we got to all of our questions. I will give everyone one more minute to get some questions in if you'd like, while I sort of plug what's coming next for build. So we do have 60 sessions for build. Now we are coming towards the end of the week, at least on the East Coast in the US here. It's almost the end of Thursday, and then we have sessions on Friday, but we still have a full slate of sessions tomorrow. Some that I'm actually excited about. We have actually some community sessions tomorrow where customers are coming, and Mapbox has minimal involvement in them presenting and telling their story, how they use Mapbox, the challenges they have, the solutions they found. So if you're interested to hear it straight from the mouth of a customer, definitely check out some of those sessions. And while I was plugging those, we did get another question. So Luke asked, is there, oh, we have a few more coming in. No problem. Is there a Windows Linux version of the native Mapbox vector raster map library for our programs? Do you know, Jake?
I do not know off the top of my head.
Okay, no problem. Luke, we can follow up with you. And then another question. Are there any of these more complex raster array recipes in the documentation? If
Yes.
would it be possible to get a peek? Yeah.
Yeah, definitely. So in that link on creating the wind animation, I think that that's a little bit more of a complex form where you have to grab two bands out of the source data to generate wind particles, and that's going to be a U and a V component representing the wind. That recipe will look a little bit different than the recipes that I was generating today, and the filter specifically goes into how to filter both those bands and then generate the particle animation from there. There are much more complex recipes that you can create than what I showed today and what our documentation shows for creating wind animations. But we have some documentation around the different kinds of filters that can be applied through our GLGS documentation. I'll try to find a link for that.
Yeah, I'll answer the next question while you do that, Jake. Reginald just asked, will you be able to access the recording? So yes, if you're registered for Build, which you clearly are because you're here, the recordings will be available after the event. So sometime next week, you can come to the same place where you've accessed all these sessions, the Build Zoom lobby, or the console, and you will be able to find the session, categorizing the data that happened, and the recording will be posted there. I don't know the exact time next week, but we definitely intend on getting all the recordings out there. And then
Cool.
it looks like Jake was able to paste a recipe spec in the chat. Um, uh, Luke, or excuse me, Liam.
Yeah, there are a lot of different expressions that you can define using recipes. And there's a link from the source rules as well to how to make some more advanced expressions. But yeah, I think that documentation should sort of give you a sense of what you can do with recipes.
All right. Liam said this has been super helpful. So thank you, Jake. With that, I'm going to wrap it up here. We hope to see you on future sessions. And yes, Jake went into the code. There were some more potentially complex topics covered here. So come back and revisit the recording next week. You can actually pause the screen if you want and look at the code. All right. We'll see everyone on the next session. Thank you.
So, you all, thanks.